On Tomorrow's World Today, we explore the cutting-edge advances that are shaping 4 different worlds. The world of inspiration, where the wonders of the natural world amaze and inspire us. The world of creation, where ideas come to life from traditional arts. The world of innovation, where ideas and inventions move us all forward. The world of production, where innovations are mass-produced to improve our lives. From Inventionland World Headquarters, here's your host, George Davison.
For more than a century, the aerospace and defense industry has been driven by incredible advancements. And one of the biggest has been the rise of unmanned aircraft systems. During World War II, the radioplane OQ-2 was the first mass-produced unmanned aircraft vehicle in the United States. And when you fast forward to the iconic Predator drone that was used during the War on Terror, well, you can just see how much technology has evolved. What started as a simple remote-controlled drone for reconnaissance has transformed into a sophisticated machine equipped with advanced sensors, AI, and autonomous capabilities. These unmanned systems are reshaping our military strategies and changing how we approach national security. Today, unmanned aircraft systems are playing a crucial role in intelligence gathering, surveillance, and target acquisition, allowing military forces to operate more efficiently and safely. They can carry out missions in dangerous environments without putting a pilot at risk. From real-time reconnaissance to precision strikes, unmanned aircraft are giving military commanders better situational awareness and smarter decision-making tools. So how will these unmanned aircraft systems continue to shape military operations and strategies? Well, I'm going to send Greg to the world of innovation to find out.
Cutting-edge technology is taking flight right here in San Diego, California. I'm meeting with David Alexander, the president of General Atomics Aeronautical, to explore their groundbreaking unmanned aircraft systems and how they're redefining what's possible in the air today and in tomorrow's world. Hey, Dave.
Hey, Greg. Welcome to General Atomics.
Thank you very much. I am super excited to be here and learn about all the different things that you folks do here. I'd kind of like to start with a little bit of the history of General Atomics. How did it all get going?
Well, General Atomics was founded in 1955, and in 1986, the Blue family purchased the company and built 3 main affiliates: electromagnetics, energy, and aeronautical system, which is where you're at here today.
Well, what sort of spurred that diversification into aeronautics and unmanned aircraft?
Neil Blue and his brother Lyndon, they're visionaries to start with, and they are enthusiasts when anything that flies. So they really saw a vision of surveillance aircraft for the military with the advent of GPS combined with low-cost, long-endurance platforms.
And this was really the start of the Predator system, right?
That was the beginning of the Predator. That was the vision. It was a reconnaissance aircraft, long endurance, and very affordable.
But now I'm sure over the years that has really evolved.
It's an evolution of 30 years of the making, and so we would like to show you everything we have.
Excellent. Well, let's go take a look. Lead the way.
Follow me, please. So Greg, here we are on the integration floor in the factory, and behind you is the latest and greatest MQ-9 Bravo. It's the next generation aircraft.
That is, it's amazing looking. One of the first things that struck me as we walked in is the size of it.
If you roll back like we were talking before, MQ-1 started as Predator, small, long endurance aircraft using GPS. When Predator really got put into use, it was equipped with SATCOM control, so you could control it halfway around the world, and combined with weapons. So now I have full motion video, I have the weapons, I have the control halfway around the world. I can protect the warfighters without putting a pilot at risk.
Well, what are some of the capabilities that this aircraft has that the original Predator did not?
The original Predator was a 55-foot wingspan, maybe 2,500 pounds takeoff weight. This is roughly 80-foot wingspan, 13,500 pounds. So it's got way more capability to carry the sensors that are needed for all types of new missions going forward. Not just full motion video and weapons, you name it, into maritime missions. And so this aircraft can fly 48 hours, 2 days without landing. And so it gives that long persistence with even more sensors, and that's really the capability that you're seeing here today. It also provides the ability to integrate into the airspace with certification from NATO, all-weather de-ice, lightning protection, and safe separation, so you can fly in contested airspace going forward.
This is approved for being around general populace. It's got the same sort of safety measures in place that any aircraft would, and it has to adhere to that.
That was been our key, is to make this platform that can integrate into all airspaces, not just combat, and it'll open up new missions for us. So what I'd like to do is show you and discuss some of the other platforms that we have along the way.
Sounds great. I'm in San Diego, where I'm talking to David Alexander, the president of General Atomics, about the latest innovations in drone technology.
So Greg, I'd like to continue the story about MQ-9 Bravo. The predecessor of this aircraft that is displayed here was the Reaper, MQ-9A Reaper. And that started as a commercial enterprise, as a kind of a vision of our owner for telecommunications. The Air Force said, whoa, that's bigger and better than MQ-1. We want that. Bigger airplane, more useful load, more capable. And the key was turbine machinery, a turboprop, that was key. So Predator was piston engine with gasoline. And then the Army saw that and they said, you know what, we would like the Gray Eagle aircraft, but we want it with diesel fuel. And that's really what started the Gray Eagle airplanes, about halfway in between this airplane and an MQ-1.
So the different propulsion systems is kind of what drove that. What did it leap into next?
Well, next was what we call a Venger, and that's an even bigger aircraft, so about a 20,000-pound gross takeoff weight jet. So here we are using a turbofan jet engine. That has led into collaborative combat aircraft using jet engines that fly fast. So the jet engines fly higher, they fly faster, and it allows us to get into a collaborative combat program. This autonomy, affordable mass is the future right now for us.
So the future of unmanned aircraft is being created right now.
Right now as we speak.
Well, I've got to see some things today that I never thought I'd get to see, so thank you very much, Dave.
Thank you for coming.
Next, I met with Nikki Johnson, Vice President of Government Affairs and Strategic Communications, to discuss flight hours, missions, and international partnerships. So, Nikki, I got to meet up with Dave Alexander and learn a little bit about the history of General Atomics. And then he also showed me some really impressive aircraft. From what I understand, you've got some really impressive numbers that go along with that technology.
So we do. We are approaching over 8.5 million flight hours across our fleet. We've flown 556,000 missions over 40 countries. And our aircraft actually has an aircraft availability rate of over 90%. So what that means is when the aircraft is needed, they're ready to go. And that aircraft availability rate is actually one of the highest for aircraft in both the U.S. Air Force and U.S. Army's inventories.
Well, how does that translate internationally? Are you partnered up with any of our allies?
So we are. There's always been a lot of interest in our aircraft from international partners and allies, probably starting with the MQ-9A Reaper during the global war on terror, and now just providing the situational awareness and multi-domain capabilities that the aircraft offers. We have over a dozen international partners right now, and we look forward to expanding that, particularly as we move into the Collaborative Combat Aircraft, or CCA, program.
Excellent. That's one of the things that I'm actually going to talk with Mike Atwood about next.
Okay, I'll show you the way.
Hi, Mike.
Hey, Greg, good to see you.
Good to see you, too.
Yeah.
Well, Mike, I was just talking with Nikki, and we were discussing General Atomics' international involvement, how many different countries you service, and it's pretty impressive. We also talked a little bit about CCA, or Collaborative Combat Aircraft, and the XQ-67A is sort of where that started. Why was there a need for that aircraft?
About 6 years ago, we realized that we needed to work on the next generation of the Predator and Reaper families. And we realized we were at this inflection point of kind of stealth and cost and autonomy and kind of mixing those all together. And so in partnership with the Air Force, we began the initial program to build the XQ-67 Alpha and ended up inventing this concept called genus species. You know, somewhat like the automotive industry, you have kind of one skateboard, one chassis, and you have different variants on top of it. And what was so interesting about that is it allowed the Air Force to essentially not have to choose the mission that they wanted to do. Land attack, dogfighting, defending tankers were all possibilities from one aircraft. The other aspect that was exciting about 67 Alpha was the ability to go really fast. So we wanted to prove to the Air Force that we could, in about 2 years or 24 months, bring a new aircraft to the flight line. And so we proved to the Air Force on a modest amount of money that we could build a genus species and build the off-board sensor station variant of that did airborne sensing.
And that's really the first time an aircraft like that has existed, where you could take that base model and apply different technologies to it depending on what the mission is.
Especially for the Department of Defense. I'd say the automotive industry has done a little bit of that with what you've seen with different kind of platforms and different SUVs and sedans that would come off of it. But really, it was the only way to reach that level of affordability for the Department of Defense. It's very innovative, but inspired by what was happening in the automotive industry.
And I guess as we look around and see how quickly things are changing in the world today, it's important to have that be able to be done very fast.
Yeah, fast and cheap. You know, we hear a lot about combat mass and how do we bring more assets to the fight more quickly. So, having adaptability and affordability with a little dose of stealth on the side is something really special for the Air Force to have. And so, very excited. And the next couple of years, you're going to see this go into production.
Well, I'd really like to get a closer look at the technology involved with this. Can we see that?
Yeah, let's go check it out.
I'm at General Atomics in San Diego, and I'm going to meet with Steve Fournier, Senior Manager, Additive Design and Manufacturing Center of Excellence, to talk about additive manufacturing and 3D computer-aided design models.
Well, Greg, welcome to the Additive Manufacturing Center of Excellence at General Atomics. In this particular space, what we focus on is metal additive. So parts like this, made out of very hard material called titanium, starts their lives as powder, right? It's very thin powder being melted using lasers. And one layer at a time, we build this complex structure.
Wow, and now this is even a little bit different than what I'm seeing here. So this is how it comes out of the printer, but this is how it ends up. How does it get from one to the other?
So all of this extra structure are needed for the printing process. Now, at the end of the day, a human being needs to get the parts out of the printer that looks like this, and then start spending time removing components like these to really get to a final part that looks like that. And then also paint the parts and qualify that for flight before we put it on the aircraft.
So even with all of the high tech of the 3D printer, the human factor is still an important part of the process.
Absolutely.
So does a 3D printer help you get from, say, the drawing board to the prototype and up into the air more quickly than you have been able to before?
Over the years, General Atomics has learned how to design things differently. So as a result, we combine parts together, so we have less parts. And so that allows us to go from a design to a final prototype into an aircraft much faster.
So a part like this would have maybe been 3 or 4 different parts in the past and then would have to be assembled. Now with the 3D printer, it doesn't care. It just builds whatever you need.
That's the beauty of this process. And as a result, we have hundreds of parts on our latest aircraft in our fleet. And that's the testament of that this technology is real today.
So this isn't science fiction. This is actually being used in aircraft that are in the air right now.
Absolutely, and it's getting bigger and more structural every day.
Steve, this is amazing, but I really want to get another look at that 3D printer.
Absolutely.
So my getting together with Steve and seeing the 3D printing technology in action was really impressive, but I'm curious as to how all of that is going to be integrated into the future of the armed forces.
Yeah, the modern fighting force has to kind of recompose itself for the changing adversary condition. As we've seen in the modern conflicts, we can think the war is going to develop one way and then it's going to shift a different direction. The quadcopters and the conflicts that we see are constantly changing and adapting. So part of the additive technology allows us to have that adaptable airframe for that changing need, that changing mission. And right now, cost imposing, almost economically imposing, is a key tenet of the warfight. So bringing that cost down with that genus species approach is a key part. But more than that, we need to address broad fronts, long borders of countries. We can't have these soda straw fighters going out. We really have to put the fighters behind this large mass of unmanned airplanes to get the combat advantage.
And I guess that's a really great way to keep the pilots out of harm's way. You're talking about really highly trained, really extraordinarily capable pilots that you then put into a combat situation. This is a great way to keep them back from that.
Yeah, you know, it always amazes me. We take our best and brightest and put them in the worst possible position we can be, right in the threat bubble. Unmanned has this unique attribute where we can pull that man back in the battle space, and we can essentially put a large force structure of unmanned airplanes in front of that. And that creates a very, again, imposing strategy. It creates a force front where the human can kind of collaborate and augment.
And I would think that this is a great additional asset for the pilot themselves, because even with all of the modern technology monitoring in a fighter jet, they still really only see what's in front of them.
Yes, when you bring these disaggregated unmanned wingmen, they can see the whole battle space. So the level of situational awareness goes way up. You know, another interesting aspect of unmanned is you can actually forward base them. A lot of people don't think about how the planes actually get there. The fighter pilots have to go through this long range of tankers to get there. You know, they're coming from their chow halls and their bases and their barracks. The unmanned airplanes are just stored in hangars. They can kind of leapfrog out of jungles and smaller bases in the Indo-Pacific region and meet the fighters on the way there. And that's how we get huge amounts of combat mass that are incredibly cost-imposing.
And that becomes a fight that your adversary just doesn't want to engage in.
Yeah, the best way to win the war is to never fight it in the first place.
I'm at General Atomics, where I'm continuing my conversation about unmanned aircraft with Mike Atwood, Vice President, Advanced Programs. So, Mike, as we talk about these autonomous aircraft and how important they are becoming in the rapidly evolving landscape of warfare, is AI and machine learning, is that a big part of this?
We've talked a lot about the airplane and the technology of the physical product, but really the software and the autonomy brain is the ultimate pillar of what we need to do to bring the capability to the Air Force. One of the biggest challenges actually isn't writing the code or the software, but it's getting the humans, the fighter pilots, to actually have trust in the autonomy. How do you communicate intent to a machine? Do you tell it to turn left and right, or do you tell it to go shoot that other airplane? So understanding those boundaries of trust and capability is really what we're focused on right now.
The future seems pretty exciting.
Yeah, you know, in the next 2 years, we're going to see a lot of that flight testing. I'm really excited for the general public to see the growth in that. It's much like the autonomous car industry. When it first came out, it was very exciting and new, but where are we really going to use it? Where are we going to trust our families with it? And I think we've now gotten to a point over, 5 or so years where we do. I think the unmanned airplane and the autonomy is going to follow that same roadmap.
Excellent. Mike, thank you very much. Well, Dave is headed over to Invention Land. He's going to meet up with George, and I've got to get back there myself, so why don't you show me out?
Let's go.
Hi, Dave. Welcome to Invention Land.
Hey, George. Thanks for having me.
Well, I couldn't wait for you to get here. My team was telling me all these stories about 3D printing, additive manufacturing. I hope you could expand on it.
Well, we enjoyed having them there. We walked them through what we call a national asset, which is 5 million square feet just dedicated to unmanned aircraft. You're not going to find that anywhere in the world. Example is the part behind us.
Yes.
That started out as a composite hand layup part. We looked at the cost of that and said, you know what, there's a better way to do it. And there it is right behind you. It's done in 3D printing or additive manufacturing and cut the cost by a third of what it was before.
That's great. So you saved costs and picked up production.
Correct.
I saw some other images too from your team, and I thought, 5 beautiful aircraft, Dave.
What you're seeing there is what you couldn't give away a long time ago. And what changed the world to really reconsider unmanned aircraft was the aircraft right in the center there called Predator. It's one of the top 10 aircraft in the world. And it can deliver over-the-horizon control through satellite dish, full motion video, and weapons tied together with long endurance.
Wow.
Over the years, we have developed over 1,200 aircraft delivered to customers, and at one point, over 100 a year were being delivered to support the warfighter. And that's with the series that you see up there, the bigger brother, the Reaper, the Gray Eagle for the Army down below, our first jet, which is the Avenger, high fly, go fast, and then our latest and greatest Sky Guardian, Sea Guardian aircraft. Again, huge investment forward-looking from our owners, the Blue Brothers, reinvesting into the company.
Beautiful, beautiful. And then I saw this image and I thought, now that looks like the future, Dave.
Well, George, we're really excited about this airplane. Now you can see it's a flying wing, but it can stay up 3 times longer flying than any other flying wing that looks just like it, due to a special hybrid propulsion that we're working on, and it's going to be a game changer. So it's not a Me Too flying wing. This is very, very different.
Dave, thanks for everything you're doing.
Thank you.
All right, everybody, that's another edition of Tomorrow's World Today. We'll see you next time. So, how about we check out some trade secrets in Invention Land?
Excellent.
All right. And remember, tomorrow's world is where inspiration and creation drive innovation in production.